Hi guys, let's look at the next question. Question number 6. In the parallelogram ABCD, angle A and C are obtuse. X and Y are taken on diagonal BD such the angle XAD and YCB are right angles. We need to prove that XA is equal to YC. So let's draw a rough diagram of the parallelogram. Let's say this is one side, this is the other side, this is our third side, and this is the fourth side, and angle A and C are obtuse, which means A, B, C and D. So these are the two obtuse angles, and we have a diagonal BD. So this is diagonal BD. Rough drawing done. X is taken such that XAD, so somewhere like this, so XAD, so this would make a 90 degrees somehow. Yes, approximately 90 degree. I've drawn rough diagram. So this angle is 90, this is point X, and the other one is YCB is 90. YCB is 90, which means Y is somewhere here. Perfect. So this is my point Y. So XAD is 90 and YCB is 90. Perfect. So I have drawn my rough diagram. I hope you realize it takes some effort and concentration to first get the diagram correct. We need to prove that XA is equal to YC. So let's figure out XA and YC are a part of which triangle. So XA is this side, which is here, and YC is here. So these are a part of two triangles, either this small one and this small one, or I look at this ADX and the other one is YBC. So let's try and look at this. Maybe another question we can look at the triangle, which is the other one. Let's try. So let's look at these two triangles. So I have triangle ADX. This is A, 90 degree. This is D. This is X. And the other triangle I'm looking at is BYC. This is B. This is Y. This is C. This is 90 degree. Since this is a parallelogram, AD will be equal to BC. Perfect. So AD will be equal to BC. So I've got a right angle and I've got a side. Maybe I can get a hypotenuse, or maybe I can get another angle equal. Since this is a parallelogram and BD is the transversal, this angle and this angle are equal. Why are they equal? These are alternate angles. So ADB and CBY, these are equal. So I've got angle, side, angle. Perfect. I've got my answer now. Let's start writing this down. Like I keep saying, draw a rough diagram and highlight whatever you know. Let's see. So let's start writing. Number one, in triangle ADX and triangle BCY. Let's look at what points we know. Number one, AD is equal to BC. Reason: opposite sides of a parallelogram are equal. So I've got one side. What else do I know? Angle XAD is equal to angle YCB is equal to 90 degree. Why? This is given. And number 3 is angle ADX is equal to angle CBY. Why? These are alternate angles are equal. Done. Therefore, by angle side angle test, triangle ADX is congruent to triangle A is 90, C is 90. So this is C, D is equal to B and Y. So what did we have to prove? We have to prove AX is equal to YC, which means 1 and 3 and 1 and 3. Perfect. So this was my number 4, and number 5 will be, therefore AX is equal to CY. CP, CT, C. This is what they wanted me to prove. That should work well for me. Now, like I said, I took only this triangle. Had I taken the other triangle, would we still have got the answer? Let's try. So this is again a part of triangle ABX and triangle YCD. So let's draw this rough diagram. I have AXB. This is AXB, and I have YDC. See, YD and C. What do I know? Here I would know that angle B and angle D are equal. Why? Because these are alternate angles. Perfect. I would figure out that this angle and this angle are equal. Why are they equal? Because opposite angles of a parallelogram are equal, and from both of them I am deducting 90 degree. So that should be equal. Perfect. So I will be able to prove this angle and this angle equal. And I have AB will be equal to BC. Why? Because these are opposite sides of a parallelogram. So we can write this answer for the second one. So in this case, this will be again ASA test. And how would we write this? It will be AB is equal to CD. Let's give it number 6. This question is already over. This is a second method of doing it. This is opposite sides of a parallelogram. Next, number 7 would be angle ABX will be equal to angle CDY. These are alternate angles are equal. And for this we'll have to prove something. So number 8 would be angle BAD is equal to angle BCD. Opposite angles of a parallelogram are equal. Number 9, angle XAD is equal to angle YCB. This is given. So subtract 8 from 9. So subtract 8 and 9, and I get angle BAD minus angle XAD is equal to angle BCD minus angle YCB. BAD minus XAD is angle BAX, and this is equal to angle BCD minus BCY is equal to angle YCD. So this is what I've got. So from next line, so I've got number 10, 6 and 7. So from 6, 7 and 10, by angle side angle test, triangle BAX is congruent to triangle DCY. And again I will be able to get AX is equal to CY. Perfect. Let's move on and let's go on to the next question. The next question that we do is question number 7. Let's look at the question. Question 7 says ABCD is a parallelogram. Sides AB and AD are produced in a manner to E and F respectively, show such that AB is equal to BA, DF is equal to something, and we need to prove these two triangles congruent. Again, like I said, rough diagrams required. Makes sense to draw a rough diagram. These are the two parallel. These are the two parallel sides, and this is joined together. These are parallelogram. But AB and AD are produced. So let me just produce AB. So this is A, B, C, and D. AB is produced. How far is it produced? AB is produced such that AB is equal to BE. So this side and this side are equal. This is E. And AD is also produced. So this is AD is produced in a manner that AD is equal to DF. Okay. So this is F. This side and this side are equal. What do they want me to figure out? They say that prove that BEC, which is this triangle BEC, and DCF. So we need to prove that these two triangles are congruent. I've got a rough diagram. Let's see what all I know. I know this is a parallelogram, which means AB and CD are equal. This is a parallelogram, which means AD and BC are equal. So what two triangles do I have to prove? Let me just draw a rough diagram of them. This is F, D and C, and this is C, B and E. So BC and FD are equal because BC is equal to AD and equal to DF. Perfect. And DC and BE are equal because DC is equal to AB is equal to BE. Perfect. So either I can get the angle equal or I can get side equal. I have no information about the side. Since it's a parallelogram, let me try and do something. So this angle and this angle will be equal. Why? Because these are parallel lines and this is transversal, which means these are corresponding angles. Now if AD and BC are parallel, so angle A and angle B will be equal because these are corresponding angles. So angle D and angle B I have been able to prove congruent. That gives me my answer. Let's start writing this down. I hope you got this correct. If this angle D and this angle are equal because these are corresponding angles. These are the two parallel lines and this is the transversal. So these are corresponding angles and equal. Now in case AD and BC are parallel because they are parallel and this is the transversal, then this angle and this angle are equal because these are again corresponding. So this angle D and angle B eventually are equal. So let's start writing this now. Number one would be AB is equal to CD. Number two, AB is equal to BE. These two are, this is not given, this is opposite side of a parallelogram and this is given. Perfect. So from 1 and 2 I get BE is equal to BC. Perfect. Now the next one will be AD is equal to BC and I also know AD is equal to DF. This is given and this is opposite side of a parallelogram. So from 4 and 5 I get DF is equal to BC. Done. So I've got two sides equal. Let me try and prove these two angles equal. So number 7, angle FDC is equal to angle DAB. Why? Corresponding angles are equal. Done. So I've got this correct. Let's look at the next one. Number 8 would be angle DAB is equal to angle CBE. Why? Again, these are corresponding angles are equal. So from 7 and 8 I get angle FDC is equal to angle CBE. Perfect. So in triangle FDC and triangle CBE, number 10, FD is equal to BC. From this, which one number was this? FD is equal to BC is 6. Next, DC is equal to BE from 3. And last one is angle FDC is equal to angle CBE. This is from 9. Therefore, by SAS test, triangle FDC is congruent to triangle CBE. This is by number 13 and this is what they want me to prove. So this is hence proved. Perfect. I hope you realize the importance of drawing rough diagram and marking out whatever information you have so that you are able to move on into the question. Let's look at the next question. The next question that we do is question number 11. Let's look at the question. Question 11 says in triangle AM, in the following shows triangle ABC, AB is equal to AC. Okay. M is a point on AB, N is a point on AC, BM is equal to CN. So BM is equal to CN. we need to prove that AM is equal to MN also. Okay, so this one seems simple. AB is equal to AC. Number 2, BM is equal to CN. So subtract, because they are part of the same side, so subtract 2 from 1 and I get AB minus BM is equal to AC minus CN. AB minus BM gives me AM and AC minus CN gives me AN. That's my number 3, and this is the first part that they wanted me to prove. AM is equal to AN. This is hence proved. That's my first part. Next part, triangle AMC, which is AMC, and triangle ANB, which is this triangle. Let's draw a rough diagram and see what I can get. So this is AMC, AMC, and this is ANB, ANB. What all do I know? I know that AB is equal to AC, which is given. I have just proven that AM is equal to AN. Can I prove something else? MC equal to BN? No, not given. Angle A and angle A equal? Yes, this angle and this angle are equal, which is BAC is equal to CAB. Perfect, I've got my answer. So I have already got the answer. Let's start writing this down. So we got number 3. So in triangle AMC and triangle ANB, so number 4 would be AB is equal to AC. This is given. Number 5 would be AN is equal to AM from number 3. Done. Number 6, angle MAC is equal to angle NAB. Why? Common angle. The angle is common. Therefore, by side, angle, side, the angle is between the two. The angle is between the two equal sides. So by SAS test, triangle AMC is congruent to triangle ANB. This is my number 7. This is the next thing that they wanted me to prove. I have done that as well. Let's look at part 3. They want BN and CM equal. It is already in this triangle. Therefore, BN is equal to CM. This is my number 8. Why? The reason is CP, CT, C. That's my reason. This is the third part that they wanted me to prove. So this is also hence proved. Perfect. Let's look at the last part of this question. The last part of this question says prove the triangle BMC and CNB. So BMC, which is this triangle, and CNB, which is this triangle. These two triangles are equal. Let's see what I can get. So let's look at these two triangles. So in triangle BMC and triangle CNB, let's draw these two rough triangles separately. This is M, this is B, this is C, and this is N, C, and B. So BC and BC are equal. BN and CN are equal. Done. Is MC equal to BN? Yes, MC is equal to BN because we've just proven them equal. MC and BN are equal. I've got my answers. Side test. Let's start writing this down. Number 9. BM is equal to CN. Where did we get BM equal to CN? This is given. Next, BC is equal to BC, common side, and then the last one is CM is equal to BN from BN 8. Therefore, by SSS test, triangle BMC is congruent to triangle CNB. This is my number 12, Is this what they wanted me to prove? Yes, so hence proved. So notice that each part is, when you solve this, you get this. When you solve this, you get this. So leading into the next part, very well done. Good question. Let's move on. Let's solve the next question. The next question that we do is question number 12. So in triangle ABC, AB is equal to BC. Oh, so this is an isosceles triangle. AD is perpendicular to side BC and CE is perpendicular to side AB. Prove that AD is equal to CE. Okay, so let's try and draw a rough diagram first. So this is my triangle where AB and BC. So this is B, this is A, this is C. AB and BC are equal. These two sides are equal, and AD is perpendicular to BC. So AD is perpendicular to somewhere here. Yeah, somewhere here. It is perpendicular to BC, and the next one is CE is perpendicular to AB. Somewhere here. So CD is perpendicular to. So this is E, and this is D. Perfect. We need to prove that AD is equal to CE. So let's see which two triangles we want to prove congruent. So we have AD and CE. So either I can prove this upper wala triangle or I can look at the base triangle. So let's try and look at the base triangle this time, which is ADC and AEC. Maybe we should be able to get something. So let's draw these two rough triangles in rough diagram and see if we can get them equal. So this is AEC, E, A and C. This is 90 degree. And this is the next one, which is, this is D, this is A and C. So this side and this side are equal because this is common and the angle is equal. Anything else that I can prove? So maybe this angle ECA, this angle and DCA. Well, they obviously can't be equal. Anything else? Yes, I think angle A and angle C are equal. Angle A, the big angle A, which is BAC, and angle BCA are equal. Why are they equal? Yeah, because they are equal because AB and BC are equal, which means there's an isosceles triangle, which means the base angles are equal. So now I have angle, side. The side is opposite 90. Here also the side is opposite 90. Perfect. So let's start writing the answers. Number 1. In triangle ACE and triangle ADC. Number 1. Angle AEC is equal to angle CDA is equal to 90 degree. Next. So like I say, whatever information is given to you, write down that information and you would end up with an answer. Next, AC is equal to AC. This is common arm. And then the last part would be angle EAC is equal to angle DCA. These are base angles of an isosceles triangle, which is triangle ABC, are equal. Perfect. So these two are base angles. Therefore, by angle side test, triangle AEC is congruent to triangle CDA. A is C, E is D. Perfect. So this is my number 4. And number 5, I have to prove AD, which is these last two and last two. Perfect. So AD is equal to CE. This is CP, CT, C. Writing this gets you 1 mark. Or maybe it doesn't get you a mark, but not writing this deducts a mark from your hard work. Let's move on and let's solve the next question. The next question that we do is question number 13. Let's look at question number 13. Question 13 says PQRS is a parallelogram. LM points on this respectively, so that this are perfect. Let's first draw a rough diagram and see how we can move from there. So this is two sides of a parallelogram. Let's join them. This is my parallelogram. Okay, let's name this PQRS. So this is P, Q, R, and S. Our L and M are points on PQ and SR. So that PL is equal to, so this is L and MR. Oh, okay. So this is M. So MR is equal to PL. Okay. Show that LM and QS bisect each other. Now what does it mean that bisect each other? What will I have to prove? We will have to prove if they bisect each other, which means let this bisecting point be P, or let it be, let's say, X. What I'll have to prove is SX is equal to QX, and what I'll have to prove is MX is equal to LX. So this is what I have to prove if I have to prove that they bisect each other, which means X is the midpoint of both SQ as well as ML. So let's look at these two triangles, which is SMX and LXQ. What do I know? This angle and this angle will be equal. Why will they be equal? These are vertically opposite angles. These two lines are parallel, which means this angle and this angle will be equal, alternate. Similarly, this angle and this angle will be equal, alternate. But this is no test. What else? I should try and prove one side equal. This I already need to prove. This also I need to prove, which means I have to prove that somehow SM is equal to LQ. I think I know the way to do it. Let's start writing this down. So number one, SR is equal to PQ. Why? Opposite sides of a parallelogram are equal. And the next part which is given to us is PL is equal to MR. So subtract 2 from 1. So what I'll get is SR minus MR is equal to PQ minus PL. So SR minus MR, what it gives me is SM, and PQ minus PL gives me LQ. That's my number 3. I think I've already got this. LQ and SM are equal. Done. I've got my answer. This will be angle side angle. So let's draw these two rough diagrams. This is my XMS and this is XLQ. Let's start writing. Number 4. We said this angle is equal. We said this angle is equal. And we said this angle is equal. Perfect. And we got this side equal. So whether we want to call this angle side or we call this angle side angle, whichever way, doesn't matter. So angle XSM is equal to angle XQL. Why? We will just write this. Next is angle SMX is equal to angle QLX. These are alternate angles are equal. These are parallelogram, which means these sides are parallel, which means this acts as a transversal. And number 6, we get SM is equal to LQ. This is from 3. Therefore, by angle side angle test, triangle SMX is congruent to triangle S is congruent to Q, M is congruent to L, X is congruent to X. So this is my number 7, which gives me MX is equal to LX and SX is equal to QX. This is CPCTC. Therefore, LM and QS bisect each other. Perfect. That brings me to an end to this video. Let's look at some homework questions. So the question that you will do as homework will be question number 8, question number 9, question number 10. Thank you so much. Take care. Be safe.